The general formula for an alpha amino acid is RCHNH2COOH. Part A. The alpha amino acid cysteine R equals CH2SH shows optical isomerism. Draw 3D diagrams to show the optical isomers of cysteine. Here we're given the general formula of an alpha amino acid. If we try and draw this as a 3D structure, we would have our central chiral carbon, our R group, a dashed wedge with NH2, and a solid wedge with hydrogen. And then on the same plane as R, we would have our carboxylic acid, or our COOH. But then we need to replace R with the R group that we're given in the question, which is CH2SH, so we can just add this in. And we're asked to show optical isomers, and an optical isomer means that it's got a mirror image. So if we draw the mirror image of this structure, we would again have our central chiral carbon, but our dashed wedge with NH2 and our solid wedge with hydrogen are on the opposite sides. And so is our carboxylic acid group. Our R group remains at the top though. And these are our two optical isomers of cysteine. To get the 2 marks for this question, you must have both structures correct. Part B. The alpha amino acid lysine R equals CH2,4NH2 reacts with an excess of dilute hydrochloric acid to form a salt. Draw the structure of the salt formed in this reaction. So if we draw the 2D arrangement of lysine, we can have our hydrogen, our carboxylic acid group, our amine group or NH2, and then our R group, which is CH2,4 connected to NH2. But we are reacting this with dilute hydrochloric acid. So what happens is we're going to replace the NH2 with NH3+. So this will turn into a 3, and we'll have a positive charge on the nitrogen. And this 2 will turn into a 3 with a positive charge on the nitrogen. But because it's a salt, we also are going to have our chlorines that are paired with these positives. So we'll have Cl- and Cl-. So this is the structure of our salt. If we were reacting with a dilute base instead of a dilute acid, we would change the carboxylic acid group into a carboxylate ion. But because we're reacting with an acid, we're not going to have any effect on our acidic carboxylic acid group. To get the 2 marks for this question, you need to protonate both amines, so turn the NH2s into NH3+, and pair them with your chlorines. Part C. Alpha amino acids can react to form proteins. A short section of a protein chain is shown below. A student hydrolyzes the protein with hot NaOH, aqueous. Draw the structures of the organic products formed from this section of the protein. So what's happening is we're going to break this amide bond when we react with hot base or hot NaOH or sodium hydroxide. And what we produce is our first structure where we keep everything the same except we're adding a hydrogen onto our NH, and then we're going to have a carboxylate ion, so O-, and we need to pair this with an Na+. So that's our first structure. Our second structure is going to be what's left over, so we're going to have a carboxylate ion again, which is paired with a sodium, and then we're going to have the rest of the structure the same until we get to the end where you've got your double bonded oxygen or your carbonyl. Here it's going to turn into a carboxylate again, so you're splitting this bond as well. And finally we need to have our added hydrogen on the NH group. So to get the 3 marks, you get 1 mark for each group that you've hydrolyzed. So that's each O- NH plus that you've written. So in your first product, that's going to be 1 mark, and then in your second product, that's 2 marks.